Take us from there into additive packaging, the differences it makes and could make in the coming years.
That's not my slide.
You have some slides for us.
That's my slide.
Slide, okay.
I could try, but maybe not.
This is your slide. We have the right one now? No?
Not yet. Well,
We could move over to...
no, that's all right. So we're here now.
Okay.
Well, I can tell you a little bit about the way we're approaching additive building of copper high-resolution interconnects at Sienta, and Muhannad has done an incredible job of introducing the problem. I'll dive deeper into how it impacts the energy crisis that we've already talked about and how manufacturing fits into that. So some of you have heard about AI memory bandwidth wall, the biggest AI hardware challenge today associated with data center inefficiency, but boils down to the wiring density in the AI chips. So AI chips have two problems today associated with advanced packaging specifically. One is the density of the wiring, and this is when we talk about bandwidth density, interconnect density, that is currently lacking. And the second one is the capacity. Currently, one of the biggest bottlenecks in the world of manufacturing AI chips is associated with advanced packaging. There's only one player who produces this high-resolution interconnects at scale, and they have the monopoly on this technology. Now, how does manufacturing fit into that? And if you look on the left-hand side, it's a very nerdy slide that shows you the improvement in the compute density in the last 30 years. Compute density has increased over 1 million times due to incredible breakthroughs in manufacturing. Some of you have worked at ASML, so you know I'm talking about lithography, EUV specifically. It has enabled us to scale transistors to almost physical limits, and that was really the revolution. And this is why, now what we're looking at is increasing the density of interconnects in the same way that EUV has done for transistors. That's the red curve. In the same 30 years, it has improved only 100x times. So there's a massive gap. So this is the AI memory bandwidth wall. How do we play? We've invented our own way of additive manufacturing of copper interconnects. It's based on actually PhD research I've done at the Australian National University. That's the Australian link. It's called localized electrochemical manufacturing, or LEM. And what it allows us to do is deposit high-resolution copper interconnects using additive technologies by combining both patterning and electroplating. So it's quite different. It is potentially a step change for the industry because it solves for two things. One is the resolution and size of the package. So it solves the bandwidth wiring density limitation. And two, because it's highly efficient and fast, it triples the productivity and it enables to solve the capacity gap that currently exists within the AI chip ecosystem. Now, a little bit about practically, what have we been able to demonstrate to prove that it actually works? On the right-hand side, you can see a demonstration of our high-resolution interconnect. This is a 5-micron structure that we built last year. We've done cross-sections to show the copper quality using this method is comparable to what the industry is used to. Now, on the left-hand side is a little bit nerdy, but exciting. This is 1-micron demonstration of a copper RDL, something that currently is not possible using conventional technologies. The roadmap of the organic RDL stops at 1.4 microns. We've demonstrated now 1 micron. So it really allows you to extend the copper roadmap to where it needs to go. Practically, solving the memory AI wall. So here is the exciting bit. We have a way to extend copper all the way, not to just keep up with the compute and where it will go, inevitably, but actually completely catching up and closing that gap so that your interconnect bandwidth is as fast as transistors. So this is the goal of Sienta over the next 4 years. We're going to close that gap. We're going to solve the memory AI wall. And we're definitely going to work with CPO. We're going to work with other technology substrate innovations that are present on the panel. It's going to take everyone. We're going to have to come together. But we're a new way of building high-resolution copper interconnects.
Very, very interesting. Thank you.